doing under superposition theorem. A slight difference for it in the previous four sums, please observe it. In this circuit given to you, you need to find current I by using the superposition theorem. Again, let's repeat it. When I say superposition theorem, it says you need to solve the circuit by keeping only one independent source in it. That source can be current, either it can be voltage. So let's observe in this circuit how many dependent and how many independent voltage source are there or current source are there in this circuit. If you see in this circuit, there are total three sources. One is 70 volts, one is 50 volts, one is 2 ix. If you observe among all the three sources, all three are voltage sources. Among three sources, there are two independent sources and one dependent source. So that gives you a clear-cut hint that you need to solve this sum by using two cases. In first case, you will be doing 70 volts. In second case, you will be doing 50 volts. That's it. So let's start with case 1. For case 1, your acting is 70 volts. When I say 70 volts, my dear friend, that means I need to remove 50 volts. When I say I need to remove a voltage source, I mean by I need to replace my voltage source by its internal resistance. When I say internal resistance of a voltage source, I mean by its value is 0. When I say internal resistance of a voltage source value is 0, I mean we need to short the voltage source. So your case 1 circuit will look in this format. You will be having a resistance of 4 ohms, a resistance of 20 ohms, again a resistance of 2 ohms, again a voltage source of 2 ohms, which value will be having 2 of ix, again a voltage source of 50 volts, which you will be shorting it and replacing it by internal resistance, a resistance of 10 ohms, I, which you need to find out, 70 volts, which is acting in this. So your ix is depending. So let's solve the circuit. Since we can see there are three loops, so put the current for it, I1, I2, and I3. If you observe in all three cases, everything is voltage. Everything is voltage source for some reason. Wait time. So we have three circuits. Let's do it one by one. So first, applying KVL in mesh 1. In mesh 1, there are two resistors. Add both the resistors. So you'll be getting 22. Which current is flowing? I1. Since you're writing for mesh 1, for mesh 1 side, apart from I1, any other current flowing in both the resistors, you take it as negative. So if you clearly observe it, my dear friend, in 2 ohms, I2 is flowing, sign will be minus. In 20 ohms, I3 is going to be minus 20. After equal to, you'll be putting the voltage. If you observe in mesh 1, there is only one voltage. So your current enters into negative, so it will be positive. That will be your equation. Same thing, apply for second. Applying KVL in mesh 2. In mesh 2, how many resistors you can find? You will say 2, very nice. Add them, so you will get 12. Which current is flowing? I2 plus because mesh 2. Apart from I2, everything should be negative, right? So in both the resistance, apart from I2, is there any other current flowing? Yeah, I2. So that means it will be minus 2 I1. I3 is not flowing, so it will be 0 I3. After equal to, you will be putting voltage source. In mesh 2, how many voltage sources you can see? You will see 1. So current entry into negative, that will be positive. 2. Everything the equation should be in terms of unknown, right? So what extra term you're getting it? Ix. So let's remove it. So if you observe keenly, your Ix and I3 direction. Your Ix and I3 are in the same direction. So you can mention Ix is equal to I3. So you have put the equation of Ix in the previous equation. So you get minus 2 I1 plus 12 I2 plus 0 I3 equal to, this will be 2 I3. instead of ix, you have three substituted with respect to I. Shift over here, so you'll get minus 2i1 plus 12i2 minus 2i3 equal to, this will be 0. So that will be your equation number 3 unknowns, 3 equations. Let's wait for the third. Your statement will be applying KVL in mesh 3. We get in mesh 3. If you observe, I am assuming it that you will be having in a network in your notebook. In mesh 3, if you see, there are two resistors. Add both the resistors, 4 and 20. So you'll be getting 24. So plus 24 I3. With I3 mesh 3, so I3 will be positive. Apart from I3, all the current should be negative. So if you see, in 20 ohms, I1 is flowing, so you'll be writing minus 20 I1. I2 is not flowing, so you'll be writing 0 I2 equal to, my dear friend. So after equal to, you'll be getting the voltage source. You'll be having one voltage source. If you observe the current properly, the current I3 is entering into positive, so you'll be getting minus 2 I. Already, my dear friend, you have found the value for ix. Ix is nothing but equal to I3. Put the value of I3 over here. So you will get minus 20 I1. This will be 0 I2 plus 24 I3. This will be minus 2 I3. Shift this side. This will be minus 20 I1 plus 0 I2. This will be 26 I3 equal to 0. This will be equation number. So you have three unknowns, three equations. Solve it by using a scientific calculator. You will get the value of I1, I2 and I3. So that will be the logic. But that's not the end. Again, further you will solve it after getting all the values. So after calculating the values of I1, I2, I3 by using a scientific calculators. So let's find the value for I, which we need to find the question. So your I is equal to I3, but the direction. So your I is equal to I3 or I1 or I2. It depends upon you, the number of unknowns as how you take it. So in this case, your I, wherever your I is, in this case, you have taken I2 unknown, right? So you will be writing over here, the I is equal to I2. And now it depends, the direction of I and I2, is it same or different, my dear friend? So you will say it is same. So if it is same, you will be writing flat. So the value of I2, which you got it in this case, was nothing but, so you're putting it. So that will be a value for I. Since it is case 1, my dear friend, so you will be writing I. That's the value. Okay. So now you will be going for second case where your 50 volt would be acting. So now let's go for second case, my dear friend. So your case 2 acting 50 volts. If your 50 volt is acting, that means now your 70 volt needs to be removed. When I say a voltage has to be removed, that means it needs to be replaced by its internal resistance. When I say about its internal resistance, it needs to be replaced by its internal resistance value, which is nothing but 0. When I say the internal resistance value is 0, that means your voltage has to be shorted. So your equation would be, my dear friend, that the network will be, the 70 volt will be shorted, the circuit will be having a 20 ohms or 2 ohms, this format. Your voltage source will be a plus minus, in this case 2 of Ix. Again a voltage source which have been dependent, which is acting in this current circuit, having a resistance of 10 ohms, the current I which you need to find out, and again having a resistance of 4 ohms, and the current Ix is depending over here. Since there are 3 groups, so if you considering 3 unknown current, I1, I2 and I2. Again I need to find the current value for I, so let's do it, my dear friend. Again we will be writing 3 equations, 3 mesh 3 equations. The equation will be applying KVL in mesh 1, we get resistance you are getting it over here, there are two. Add them, my dear friends. You will be getting plus 22 I1. Why plus? Because you are considering mesh 1. Observe in this two resistance, is there any other current flowing for it? Yes. I2 and I2. This will be minus 2 I2. This will be minus 20 I3, which will be equal to 0. That will be your condition number 2. Let's go for second mesh. I hope you have drawn the network in your book. So it will be very helpful for you to write the equation and understand the equation what I am writing for you. So the second equation would be applying KVL in mesh 2 we get. So it will be in this case, you have two resistors, my dear friend, and then you will be getting 12 I2. Observe in both the resistance, is there any other current flowing through it? You will see yes, I1 is flowing across 2 ohms, sign will be negative. I3 is not flowing, that will be 0 I3 equal to, after equal to the right voltage source. In this mesh there are two voltage sources. One is dependent, one is independent. So write both the things. When I2 enters into dependent voltage source, it enters into negative, it will be positive 2ix. When it enters into independent, it will be negative, it will be positive. The rule says the equation should be in terms of I1, I2 and I2. So you do this, convert Ix in terms of I1, yeah I2, yeah I2. It depends. So observe the network carefully. If you observe the network carefully, your Ix is equal to I3. And the direction is same, so it is plus. So wherever you will be getting Ix, my dear friend, put down equal to I3. So here this will be minus 2I1 plus 12I2 equal to 0I3. This will be 2I3 plus 50. Shift all the variables this side. It will be minus 2I1 plus 12I2. This will be minus 2I3 equal to 50. That will be your equation number 3 unknowns, 3 equations. Let's go with the third one, my dear friend. Applying KVL in mesh 3, we get, and so on. In mesh 3, if you observe, there are two resistors. Add them, if you get it, you will be getting 24. Current flowing is I3. Mesh 3 to positive. Apart I3, any other current flowing will be negative. If you observe that both the two resistors, apart from I3, there is one current flowing, that is nothing but I1, which is flowing across 20 ohms. So that will be minus 20 I1 plus 0. So equal. So in mesh 3, you will be having one voltage source, that is nothing but your dependent voltage source. The I3 enters into positive, where sign will be negative, minus 2ix. Ix is nothing but equal to I3, because as said, everything should be in terms of I1, I2 and I2. So this will be minus 20 I1, this will be 0 I2, this will be plus 24 I3, this will be minus 20 I3. Shift this side, this will be minus 21 I1, 0 I2, this will be 26 I3, this will be 0. That will be equation number 3. After getting all the three equations, my dear friend, solve by using a scientific calculator, you get the value of I1, I2 and I3. The unit in all the three cases will be amperes. After the calculation of all the three values by using a scientific calculator, ultimately I need to find I, that is nothing but equal to, my dear friend, I2. So which you got is 4.57 amperes. Since it is the case 2, let's denote by I double dash. So at the end I need to find I, which is nothing but equal to I dash plus I double dash. So your I will be the addition of both the terms, which I think it should be done by you guys. So thank you so much guys for being there with superposition theorem. That's all. You have the combination of all 5 sums of superposition theorem. So any sum, any combination, you should be able to solve it. Don't worry about it. So let's go forward for it for the next topic, which we'll be having. That will be your Thevenin's theorem, a combination of a Thevenin's voltage and a current, then an equivalent circuit. So in that case, you'll be requiring the basic concept of mesh and super mesh. So that's the basic concept. So before going for Thevenin's, please revise mesh and Thevenin's. Will be having a Thevenin session next after. Thank you so much. Signing off.